Good morning. Let us discuss chromium plating today. So I have discussed what is electroplating, governing principles, what is governing principles of electroplating. There are mainly three principles which govern electroplating. They are polarization, decompression potential, and over voltage. Today, let us see how electroplating of chromium is done. So chromium electroplating is having variety of applications. It is mainly used for decorative finishing in automobiles. It is used in surgical instruments. It is used in your fast track watches. So watch chains, isn't it? Used in optical instruments. And we have two types of chromium plating. One it is used for decorative purpose. Other one is hard chromium plating. The hard chromium plating is used in case of industrial engineering applications in power tools, etc. So how this chromium plating is done, whether it is a decorative purpose or it is for hard, how it is done, let us discuss today. The chromium plating is usually done by electrolyte consumption method. So what is electrolyte consumption method? You know. So we are not going to use chromium anodes. Instead, we are going to use chromium in the electrolyte. So why chromium anodes are not used? Because chromium is a passive metal, right? So chromium, aluminium, nickel, tungsten, I mean they have got a boon from nature to what to rectify themselves, to protect themselves from corrosion. In a dip chromium in acid, it will form its respective oxide. That oxide covers the entire metal and it prevents chromium from further undergoing oxidation. To prevent chromium from releasing the chromium cations. If cations are not released, then reaction of chromium 3 plus will not occur. Okay, so in order to prevent that, we are not going to use anodic consumption method, we are going to use electrolyte consumption method. There are two types of chromium plating. One is hard chromium plating, other one is decorative chromium plating. So irrespective of the methods, what do we do is we usually give a nickel undercoating for chromium plating before chromium plating is done. So irrespective of methods, whether it's hard or decorative chromium plating, so the anode and cathode and electrolyte are same. For the anode usually used is inert. So usually we're going to take insoluble anodes like lead and tin coated with lead oxide for both chromium hard and chromium decorative plating. The cathode as usual the object to be placed. So you know whether it's anodic consumption method or electrolyte consumption method. Always what is the cathode? Cathode is the base metal object to be plated. So electrolyte, we want chromium ions. From where do you get chromium ions? We're going to add chromic acid. So the acid will be chromic acid mixture, chromic acid and sulfuric acid mixture when taken 100 is to 1 ratio. Okay, so we're going to take an anode here. These are base metals. This anode is inert. So anode, as what as discussed, it is lead tin alloy coated with lead oxide. This is the base metal, and plating bath solution, that is electrolyte, as your chromic acid and sulfuric acid, which is 100 is to 1 ratio. At anode, oxidation occurs, and at cathode reduction occurs. So what are the other what plating conditions? Let us see. The current density for decorative chromium plating is 100 to 200 milliamps per centimeter square. So what do you mean by current density? Current density, it is nothing but current per unit surface area of the object to be plated is called as current density. Current per unit surface area of the object to be plated. What is the object here to be plated? It is the cathode. So current per unit surface area is called as current density. So decorative chromium plating, it is 100 to 200. For hard chromium plating, it is 215 to 430. So current efficiency for both, for decorative chromium plating is 8 to 12%. For hard chromium plating, it is 10 to 15%. For pH, for both it is same. Why? Because both the electrolyte or the bath, it is same, right? So electrolyte itself, it is called as plating bath solution. Okay, so what is electrolyte? It is chromic acid and sulfuric acid. What it is acid, right? So the composition is same, 100 is to 1. So the pH remains same, it is 2 to 4. Temperature, it is 45 to 55 degrees Celsius in case of decorative chromium plating. In case of hard chromium plating, it is 43 to 66 degrees Celsius. So at anode, what happens? The potassium dichromate will undergo, potassium dichromate will release K2Cr2O7, undergoes oxidation. So what happens? I'll just tell you. This is the under the reaction. So K2Cr2O7. So we have H2Cr2O7. This is your potassium chromic acid. So this will get liberated to Cr2O7 2 minus and 2H plus and electrons. Okay, so here the oxidation state of chromium in chromic acid is 6 plus. So first this will undergo oxidation. Okay, this will undergo oxidation to liberate chromium, and first this will undergo reduction. Okay, so chromium 6 plus will accept 3 electrons to give you Cr3 plus. So this Cr3 plus further accepts 3 electrons and gets reduced to Cr. Okay, so what happens here? What happens here? So first initially here at anode Cr3 plus chromium will be liberated, Cr6 plus will be liberated. The Cr6 plus will come at cathode. Here the Cr6 plus will reduce to Cr3 plus, and this Cr3 plus will further reduce to chromium and get deposited on the surface of cathode over here. Okay, this is how the chromium plating occurs. So the applications, it is used in surgical and optical instruments. It is used for decorative finishes on automobiles. You can take your bullet, you can take your drilling machines. Okay, bullet, your car, that is chromium plating is done. Yeah, the hard chromium is done for drilling machines, your bore wells, etc. So before going why here, you can ask why chromium plating is done only using electrolyte method. Why it is not done using anode consumption method. So as discussed earlier, the chromium anodes strongly passivates in in acid media. That is one reason. Other reason is, so what happens is the anodic efficiency is 100%. That is, at per every minute 100 Cr plus 3 will be liberated. But at same time only 10 to 20 Cr plus 3 will be converted to Cr. So because of this, the concentration of Cr plus 3 will increase in the what? In the plating bath solution. If the concentration of Cr plus 3 increases, so what? So because of this, what happens? There will be black deposit on the surface of the base metal. So who will buy? There are black deposits. So if there is a watch here, if I have a black deposit on this, will I buy? No. Everyone want crystal clear. Is it right? If the surgical instruments, if there are optical instruments, there are black deposit, will I buy? No. That is one of the reasons. The anodic efficiency is 100%, but the cathodic efficiency is 10 to 20%. So because of that, there will be increase in concentration of Cr plus 3 inside the deposit. So because of that, what will happen? Cr3 plus will deposit on the surface of the cathode, which gives black deposits. That is one of the reason. Another reason is the chromium has high efficiency negative electrode potential. So that is the other reason. So because of these reasons, we are not going to use chromium anode. We're not going to deposit chromium using electroplate chromium using anode consumption method. Instead, we're going to use electrolyte consumption method. So as I told, the applications, it is used in your automobiles. You can see, take your bullet, the entire handle, everything, it is made up of chromium plating. It is plated by chromium. That is decorative finish. I'll just show you the video here, automated video. You can have a small look of the applications of chromium.
Everyone appreciates the shine of chrome, but
see here the bullet handles, the handles and that mud guard, everything is chromium plated. Of course, it's made up of some other metal, but it is chromium plated. The surgical instruments, right? The hammer. So all these are chromium plated. Okay.
Chromium ore is not overly abundant and therefore expensive. Also, pure chromium is a brittle metal that is hard to work with. How then can just about anyone afford beautiful chrome accessories? This is accomplished by the deposition of chromium ions onto a base metal using electrolysis in a process called chromium electroplating. The preparation of the base metal is essential for quality plating. The base metal must first be cleaned to remove both grease and oxidation. Often the metal is then chemically etched to improve adhesion of chromium ions. In the electrolysis unit, the base metal is used as the cathode, and a lead bar immersed into chromium solution is used as the anode. As direct current flows, chromium metal is deposited onto the base metal. When the desired depth of plating has been reached, only a final rinse and polish is needed. Even a thin layer of chromium provides the beautiful, lustrous finish. Objects subjected to greater wear need thicker layers of chromium. As an added benefit, the chromium
These are
provides a
the
protective layer for the base metal.
so these are the beautiful chromium plating on automobiles. Maybe any car you can take. It undergoes chromium plating.
Beneath.
Yes. Thank you.